The Months Insight page is designed to offer a detailed view about data for the months. So in the application, for example, if you choose July 24 that I've chosen here, and then you get those mood charts, energy, and all different types of part charts for diet, physical symptoms, activities. And here we've got the sleep duration. And this is the summary of the months, 7th of 2024. So I will break down how we use D3.js to create different types of charts. D3.js, that you can have a link here, is a JavaScript library for creating dynamic interactive data visualizations in web browsers. And it allows us to bind data to a document object model, DOM, and apply data-driven transformations to the document. This library provides a wide range of tools for manipulating the DOM, which are essential for drawing charts. So as you saw in our document, we've got different types of charts. And we use D3.js to create those ones, bar charts for mood data, line charts for energy levels, and then we have these pie charts for diet, activity, and physical symptoms, and we have a bar charts here for sleep duration. Each of these charts is drawn using specific D3 functions. They handle aspects like scales, axes, and shapes. By integrating D3.js with React, we achieve a powerful combination that allows us to create highly customizable and interactive visualizations. So the component's core features include state and effect hooks. We use user state to store the monthly data retrieved from the server. This state is essential for holding the data that will be visualized. And use effect is employed to fetch this data whenever the month's parameter changes. For example, when I showed that I chose July 2024 to get the month's insight. Once the data is fetched, it triggers functions to draw several types of charts. And the functions, as you can see here, and they're listed, are called draw mood chart, energy line chart, pie chart. For pie chart as a general function for diet, activity, and physical symptoms, and sleep duration, which is a bar chart for sleep duration. And you saw those in the application. So the way that we fetch data is very similar to the previous slides, previous chapters. We use the hook use effect. And use effect is responsible to manage side effects in our component. Specifically, it's responsible for fetching data when the month's parameter changes. So the dependency array months tells React to run this effect only when the month's value changes. So this part, this line, makes it clear. And this prevents unnecessary data fetching and chart rendering. And it optimizes the performance because it only renders the charts again when this dependency variable changes. And then we've got the get here, the Axios.get, which performs an API call to retrieve the monthly data. The URL includes the months parameter, as you can see here. This is the URL, and this is another endpoint that we have developed. And we saw this when we were talking about the back end. And the URL includes the months parameter, as I said, and specifies which month's data we need. This call sends a request to the server, returns a promise. And then, here we go. And once the data is retrieved and the response was successful, then we have all these draw charts, a mood chart, energy line chart, pie charts for different types of data and sleep duration. So the first thing that we do is clearing the content of mood chart before going forward. After that's clear, then what we can do, we can calculate the weighted average. In order to calculate the weighted average, we use reduce. We saw reduce before, that it iterates over an array. For example, here we're using a reduce to sum up all the elements of an array and get one result, which is 6. The same thing for weighted average, that what you have to do in this function is, first of all, you have to multiply the mood value with its weight, then you have to sum them up. So this is the way that we use reduce, which is a more complicated version of the previous example. Because we calculate this weighted average for each mood, therefore we need to use map. And as we've seen before, map function is used to create one array out of another array. For example, if you double each element of this array, then you get 2, 4, 6. And then we use map in the same way, and we iterate it over the key of each mood value, aggregated mood values. So then we have the chart data. This is exactly what we want to have to give it to D3 and create our charts. One point here is when we calculate the value here, because until now we only had the aggregated mood values, which was a summation of the weighted mood values. And then when you divide it by the total weight, then you get the average value. So this is something that we do like while we are doing the map here. So if you wonder what this line does, at 0 gets the first character and then converts it to uppercase. And slice 1 gets the second character on whites and then put them all together. So it's only to make the key starting with the capital letter. Okay, next we are going to set up the margin and dimensions, top, right, bottom, and left, and the width and height. After doing this, we have one SVG element and we append to it. And we define what the width and height of this SVG is. And we calculate it quite dynamically based on the width and height and margin that we have for the chart. And then also we have the X and Y axis. And because X-axis is mood categories, that's why we're using scale band. And then for the Y-axis, because of it's our mood values, that's why we're using this linear scale. And the last part, we have this. So bars representing each mood are appended to this SVG with the heights based on the weighted average. And we also add mouse over and mouse out event handlers to change the bar color when hovered over. You've seen this before. When we hover over our charts here, the color changes. And mood chart too. To begin with, we clear any existing content from the energy chart div using d3.select, energy chart, select all, and remove. With this, we start with a clean state for our new energy line chart. Next, we have to prepare the data for the chart. This is how we are preparing the data. And we use map to create line data, which includes dates and energy levels. This map transformation is important for plotting the line chart accurately. Then what we do next is, again, margins and positions. We define the dimensions of our SVG container. Margin, widths, and height variables are set up similarly to those in the mood chart. And then we can allocate space for the chart and its labels. Yeah. And in the next step, we have like an SVG element, which is appended to the energy chart selector. And a G element is created and translated to account for the margins. This is where we will draw our line chart. Then we have the X-axis. And for the X-axis, we use D3's scale time to map dates to the horizontal axis. We then append the X-axis to the SVG. And we format it to display dates and position the axis labels, as you can see. And next one is the Y-axis. And the Y-axis is created again using the scale liner to map energy levels to the vertical axis. The Y-axis is appended to the SVG with labels indicating the energy levels. And then we have the line itself. This is how we create the line. The line itself is drawn using D3's line function, which takes the data and maps it to the SVG coordinates. Then there's the last part. In the last part, we append a path element to the SVG to represent this line, setting the stroke color and width. So if you look at data on line data, this is to bind line data to the path element. And then when you look at the last part here, so I talked about data on line data, and now I'm talking about line. So In the line part, we use the bound data to generate the path. So we have two sorts of data. We've got the line, which is to generate the path, and we've got a line data to bind line data to the path. Before moving on to the next chart, I'm going to go back and show you a call function that we use for x-axis and y-axis. This is the call function for y-axis, and then we use the same thing a little bit differently for x-axis. And what does this call function do? This is the main question. The call function in D3 is used to apply a function to a selection. For example, in this case, it's applying the axis generator function to the selection, which in this context is the G element, where the axis is appended. It's so G. And the detail of it is D3.axis bottom X creates a new bottom-oriented axis generator using the scale X. The axis is positioned at the bottom of the chart. And then we've got tick format, which specifies the format for the tick labels on the x-axis. And then we've got the text size, which is 0. This sets the length of the tick, the text, the small lines extending from the axis to 0. Effectively removing the tick lines, only the labels will be displayed. And then the other one is tick padding 10, which sets the padding between the tick labels and the axis line to 10 pixels, ensuring the labels are not too close to the axis.